All right, hi, I'm Steve. Title of my talk, Seeing is Believing, Pupillary Dilation to Illusory Motion. But one thing that we have to sort of talk about first is what is the pupil's sort of relation to neuroscience and psychology before we jump into that illusion. So the pupil response is motivated by accommodation and the light reflex. First off, this has been established many years ago. Essentially what this means is that our eyes will get wider to take in more information, whether that means we need to take in a lot of information in a vast scene, or if we're just in a really dark lit room and we need to let more light in so our pupils get larger to allow that to happen. But what I'm interested in, aside from that, is the pupillary dilation response that occurs as a result of arousal. So arousal it has a few different subcomponents. It can mean a few different things. If you're thinking about a complex math problem, or if you're trying to remember something, but you're just like on the sort of the tip of your brain, I guess, and or sexual arousal. But one thing that I was predicting is that visual illusions are something that's particularly arousing, at least anecdotally. When we see a magician perform something impossible, we're aroused by this impossible perception. So watching a magician perform a trick is a little bit uncontrolled, and in a vision lab we like to use a little bit more of a constrained stimulus or pattern. So this is one very particular pattern which, if you modify in a very precise way, you can elicit an interesting perception. I'm not sure if you can see it, hopefully you can, but it should look like it's like waving about as you move your eyes across the pattern. This interests me because we don't really change much from this symmetrical pattern. We just make it a little bit asymmetric, and then all of a sudden we start to see something that just doesn't exist. A lot of things go into making this type of illusion. The black and the white surrounding the blue is a prerequisite in order for it to occur. The blue and the green color pair is also necessary. This specific type of orientation and the way you move your eyes is necessary. But we don't really know why it occurs. We just know all of the components that go into making it happen. So I was interested in determining whether the pupillary dilation response will show us if we actually are physiologically aroused to this visual illusion. And so what I found is at least in the preliminary evidence that this is in fact the case. So we'll have our stimulus onset, and then this massive light reflex where the pupils are constricting. This is unavoidable when a bright image is placed onto the screen. But then as the pupil is sort of recovering from that initial light reflex, you see that the pupillary difference in its dilation profile changes depending on which pattern is on the screen, with a greater dilation response for the illusion. So it would be tempting to just go ahead and say, okay, so the illusion is causing a pupillary dilation compared to the non-illusion, but there's one other aspect in these patterns that could be driving that difference, and that's just that they're different patterns. So I went ahead and, using the same rule that creates the patterns, changing the different type of orientation template, we compared these images. So now it has the same pattern rule but without the illusion, and we see that not only does the difference disappear, but it also reverses to some extent. So now there's like a slight, maybe not so convincing pupillary dilation to symmetry. So what I've derived from these experiments is that, the asymmetric illusory motion patterns dilated pupils more so than symmetric patterns. And this is particularly interesting to me because in the published literature, perception of motion is supposed to constrict your pupils, and symmetry has been found time and time again to be associated with positive valence and high arousal. Thank you.